I hope the screen is visible to everyone. Hello, am I audible? Yeah, yeah. So we will start the last session of this very interesting NPTEL course, Development and Applications of Special Concrete. So good evening to everyone. I am Swapnil Balasad Godke. I'm currently working as a doctoral research scholar at the Indian Institute of Technology, Roorkee. So I'm also working as a teaching assistant for this course under the Professor Sudhir Mishra sir. So we'll start with the first of all recap of week 8. So week 8 is totally discuss about the polymers, polymer concrete, precast, then compaction of the concrete. These all things has been discussed in the week 8, and we will give get it some brief idea about the all the lectures. I hope you all are also going through the lectures, and some of you are completed also. So if you have any doubt in between, you can ask. So what is polymers or polymer concrete? Because we know the concrete is mainly about the some inert materials and some are binding materials. So in the case of the aggregate bound with the binders, binder is a cement. But is there any other material which is available which can bind these inert materials? So we have polymers and asphalt. So today we will discuss about the polymers. Asphalt is mainly about the pavement materials. So three types of polymer concretes are available. First one is polymer is used directly as the binder to replace the Portland cement in gluing aggregate together. Means there is a presence of cement or may not be a presence of cement, but the binding properties will be given by basically only polymer, not by the cement. So how we will see in detail. Second one is polymer is applied as an impregnating agent to penetrate a Portland cement concrete member to enhance its properties. So we already have the some of the concrete specimen, and then we will impregnate that polymer into that pores. So that is the second form of polymer concrete. Third one is that polymers we will use as a admixture or as a replacement of the water. So this is the third. So in polymer impregnated concrete and latex modified concrete, that is third one, the polymer works together with the cement binder. But in the case of the polymer concrete, the polymer acts as a sole binder because there is a no water available. Although cement available or may not be available, water is not available. So cement will not hydrate if it is available, and that cement acts as a filler. It will only fill the pores between the concrete matrix. So the basic concept of polymer concrete is to replace the cement hydration reaction with polymerization to produce a strong and compact material. So we know the cement hydration is the process to get the CSH gel and get the hardened properties of the concrete. Similarly, to get the hardened properties of the polymer concrete, we have to go with the process of polymerization. So what is polymerization? We'll see couple of minutes. So how do the processes cement hydration and polymerization differs? Basically, Portland cement concrete binder is cement. It involves hydration reaction and water required for that purposes. It is a slow process. We have the initial setting time, final setting time. No external heat required in this case because the reaction itself emits the heat. That is exothermic reaction. Products changes with the time. Means initial period we will have a different value of the stiffness or modulus of elasticity. After some time we'll have a different modulus of elasticity. So stiffness which changes with respect to time. The hydration products changes with respect to time. Hydrated products contains voids or cracks also. But in the case of the polymer concrete, binder is a polymer and it involves the polymerization reaction. Here, no water required, rapid hardening, 1 to 2 days only. In the case of the Portland cement concrete, the days required for the hydration is more than the polymer concrete. Full hydration we consider as up to 28 days. In here, polymer concrete, absence of water, we required heat as a external. Then products remain stable over the time, low void content in the final product. So these are the differences between the Portland cement concrete and polymer concrete. So what is the polymerization? Basically, polymer is defined as a organic material composed of series of repeating chemical units, and the single chemical unit is called as monomer. If you see this image, this is the monomer. This is about some example. This is the monomer which is having the bond here CH is equal to CH2. When polymerization process takes place, this single monomer connect to the another monomer, and here this CSH2 bond is connected together. So number of monomers connected to each other, and that is called the polymer. And this N is indicating the numbers. How many number of monomers connected each other? It is called as a polymer. This process is called as a polymerization from monomer to polymer connectivity. So monomer is an organic molecular species that is capable of combining chemically with molecules of the same species or with other species to form a polymeric material of higher molecular weight. Now you can see this is the monomer, and it is connected with the same chemical monomer or same chemical unit. But sometimes what happens in the polymerization process, this one monomer is there and it is connected with another type of monomer. That is also the formation of the or process. It's called as a polymerization. For that purpose, two different things are there: addition polymerization and condensation polymerization. Addition polymerization means same type of monomer connected with each other and process completes. That is the polymerization process. Whereas the condensation polymerization involves the reaction between the two monomer molecules, which are usually chemically different, to form a new chemical bond between the two. Means here we have the CH is equal to CH2. Another monomer will be the different shape and different bonding will be there, and then that together bonds by forming some chemical reaction, and that process is called as condensation polymerization. So two different types of polymerization processes are there. One is addition polymerization, where we'll get the simple addition; condensation polymerization, where we'll get the chemically different polymers to connect with each other by the chemical reactions. And the molecular formula of the repeating unit is different from that of the monomer. So basically, when it is connected to each other, it creates the chain, and that's why it is also called as a chain reaction. So polymerization, it is not automatically started. It requires to start by the action of free radical on a monomer molecule. That is CH is equal to CH2. We saw that like that we will have the free radical, which will react with the other type of bond and will create the polymerization reaction. Then we have to provide the heat also, or in the presence of promoter. Free radicals are formed by deposition of relatively unstable material called as initiator or catalyst. This image you can see here are oxygen bonded with here are also, and if you provided the heat, the chemical composition changes, and that act as a initiator. Here it connect with the some monomer, and that monomer initiates the reaction, and it's connect with another monomer. Then the chain reaction started, and chain propagation gives a polymerization reaction or polymer, and that polymer we can use into the concrete. This rate of polymerization from forming the monomer to the polymer, this rate of polymerization depends on the concentration of initiator and temperature. Means external heat, what amount of external heat you are providing. If more heat provided, the faster the reaction, and catalyst or initiator will be the more reactive, you'll get the faster polymerization process. So what will be the end products? The type of polymers like polystyrene, polymethyl methacrylate. These are the some of the types of the polymers used into the concrete, which should have a required tensile, compressive, flexural strength, and are resistance to the chemicals. Why resistance to the chemicals? If we are using into the concrete, and that concrete we are using into the some of the hazardous environment, that should not react with that polymer. That's why we required whatever the polymers we are using, that should be resistant to the chemicals. And other properties we required according to the concrete, that is tensile, compressive, and flexural strength. So how polymer concrete has been developed? First step indicates premixing a two-part polymer system composed of monomers or prepolymers with hardeners like cross-linking agents. Step 2, the mixture is added to aggregate to produce a hardened plastic material with aggregate as a filler. What is meant by filler? Filler means it will not react with any other, or it will not take part into any chemical reaction. That is called as a filler, and it will why it is called filler also, it is fill the empty spaces between the concrete matrix. So one more important point we have to consider here, that is aggregate used in polymer concrete should be dry, as polymerization does not occur on the wet surface because it requires the heat to initiate the processes. So on the wet surfaces, it will not start the process of the polymerization. And the common monomers, MMA, polystyrene, and epoxy. Other components, what apart from the monomer, what we require: catalyst, plasticizer, fire retardant, and fibers. Why it is saying no hydrated cement phase is present, though Portland cement may be used as a filler? Because we are not using water into the polymer concrete. So if no water, there is a no chance to hydrate the cement or to get the CSH gel. So that's why the whatever the cement will be available into the polymer concrete, that will only act as a filler. Then binder here will be only polymer, which will bind the aggregates. Yeah, yeah. Cement may be there or may not be there. It's depend on the your composition of the concrete. But if cement is there, that will act as only filler because water is not present. Because if you want to initiate the cement that CSH gel reaction, we require a water, right, as a reactant. What about the compressive strength? Yeah, it will become with the Portland. That's why we said now whatever the polymers we require to use into the concrete, that should fulfill the criteria of the tensile strength, flexural strength, and compressive strength, because that only giving the further strength to your concrete matrix. So this is similar to the binder. Cement is a binder. Here it is also Portland is a binder. Two different reaction happens. One is the hydration with respect to the cement, and with respect to the polymer, it will be the polymerization. So that will bind together and make the concrete. Okay. Another is that it has a higher thermal expansion than conventional concrete. Modulus of elasticity is generally lower, especially at higher temperatures. So what means by modulus of elasticity lower? What it indicates? Any idea? Does it good or bad for the concrete? It will be the disadvantage, because what happens if the modulus of elasticity is lower, means the stiffness of the concrete, that polymer concrete, is lower than the conventional concrete. If stiffness is lower, whatever the load you are applying on the same concrete matrix or same concrete cube and the same polymer concrete cube, the deformation of the polymer concrete cube will be the high because of the less stiffness or less modulus of elasticity. So we should always have the higher modulus of elasticity. But here, this is the disadvantage of the polymer concrete. And when it will come into picture, basically for the higher temperature conditions. So we cannot use the polymer concrete into the higher temperature conditions. So what are the advantages and disadvantages? Advantages: high tensile and flexural strength, because it's a chain reaction. So it will be the tensile strength will be the very high. Excellent adhesion, good chemical resistance, very low water absorption, high water resistance, good abrasion resistance, and good freeze thaw durability. Okay, but disadvantages: low Young's modulus, high creep, sensitive to high temperature, high cost, poor bonding with conventional concrete. Now we see disadvantages. We saw low Young's modulus, high creep. Creep means if you are keeping same load continuously for a longer time, the deformation will happen into the specimen. That will be the concrete specimen or then the polymer concrete specimen. But in the case of the polymer concrete specimen, because of the low stiffness or low Young's modulus, the creep deformation will be higher. Then sensitive to high temperature, it will the chemical balance or the structure will change with respect to the high temperature. High cost due to the polymerization process requires the high cost. Polymers will be the costly. Poor bonding with the conventional concrete. Poor bonding with conventional concrete means if we put the load onto the some composite of the concrete and polymer concrete, then the breaking will happen in between the bonding easily. But then where it will be used, because it has certain advantages, so where it will be used, it will use patch repair works in highways, because it will require 1 to 2 days only for hardening. Then fast curing, high strength patching of structures. Polymer mortars have been used in a variety of repair works where only thin sections are required, particularly for patches or overlays only. Polymer concrete is especially suitable for areas subjected to the chemical attack because it is having the higher chemical resistance, whatever the polymers we are using into the concrete. So that's why it will be used into the hazardous environment particularly. Now, but that environment should not be subjected to the higher temperature condition. So these are the points we have to be keep in mind while using the polymers into the concrete. So this is the form one polymer type concrete. So form two is polymer impregnated concrete. So what is polymer impregnated? Produced by impregnating monomer and catalyst into the hardened concrete and polymerizing it using heat, that may be steam or infrared. Means what is the procedure? First of all, we already have the precast concrete. Suppose we have some cylinder of the concrete or cube of the concrete. Then first of all, what we have to do, we have to dry the concrete. Why we have to dry? We already saw polymerization reaction will not take place on the onto the wet surface. For that purpose, we have to dry the concrete. Then we have to remove the air from the pores, because impregnating means we are pouring the monomer and catalyst into the that pores of the hardened concrete. So for that purpose, to get into the whole or occupy the whole pores, we have to remove the air from the pores. Then saturate pores with a low viscosity monomer or prepolymer. Low viscosity monomer. Why we have to use the low viscosity? If we want to get fully occupied that pores, the viscosity of the monomer should be low. If it is high, we have to pressurize more and it required more uh, advanced pressure equipments or pressure conditions to get into actual condition. And the polymerization will start by heating process. We'll see with the image also. This you see, we have concrete cylinder. First of all, we heat and dry to remove all the water from the pores. Then we kept into the vacuum. Into the vacuum, we impregnated monomer into the pores of that hardened concrete. Along with that, the catalyst to initiate the reaction or polymerization reaction. Then we provide the heat, and at the last we'll get the polymer impregnated concrete. So why we have to go with the evacuation of air into the or vacuum process while impregnating concrete? Because we need to remove all the air from the pores to fully impregnate the monomer and catalyst into the polymer impregnated concrete. If we are not removing fully air, will not occupy or will not get the or will not achieve the full potential of this concrete. And we, if the pores are available, we'll have the less durability. Any hazardous material come into the contact, it will go into that pores and it will affect the concrete property. So durability effect will be there. So for that purpose, we have to remove all the airs. We have to fill all the pores with the this monomer and catalyst. If you see, we are not providing here polymer. We are here providing monomer and catalyst. And the polymerization process starts when we are giving the heat. Then only polymerization started. So can anyone tell me Whether this concrete will have higher durability or lower durability compared to the normal concrete? Anyone? High. Because we are filling all the pores with the monomer and catalyst, and that convert into the polymerization. So no pores available means no external any hazardous factor or any hazardous material will come into contact, will go into the pores and will affect the harden properties. But into the normal concrete, there will be a certain amount of voids available. If they are connected, it will they will create the permeability issue also. So what are the common monomers used for the polymer impregnated concrete? That is methyl methacrylate, styrene, acrylonitrile. That's why because of the pores field, we have the lower permeability and diffusivity than conventional concrete. So where we'll use this type of concrete? Industrial floors, sewer pipes, where we should not have that sewage material. Some of the leaching will should not happen. That material should not get into contact with the outer soil or outer water bodies. That's why into the sewer pipes, seawater storage tank, structural members in desalination plants, water plants, and tunnel liners. Basically, wherever we don't want to have the pores into the concrete. Water plants also, if the water tank is there and if the concrete is having the fully pores, there is a possibility that outer water will contaminate that inside the water of the plant. So that's why the pore should be limited. And for that purpose, we can use this type of the concrete where pores will be fully occupied with the polymerization process. Tunnel liners. Tun- yes, for RCC also they are using. Yeah, yeah. Because what happens, this polymerization in RCC also, these polymers will create a oxidization layer around the what we called around the rebars, and that will reduce the corrosion also. Okay. In tunnel liners also, tunnel liners means whatever the tunnel we have excavated, that tunnel liner should be such that there is no water permeable uh, uh, from that tunnel to the inside the tunnel. So for that purpose also tunnel liners should be impermeable. For that purpose also we can use this type of the concrete. So amount of monomer impregnated depends on the total void space in concrete. Obvious, whatever the void space available, that amount of monomer will only occupied by the concrete. Vacuum or thermal drying removes air and water, increasing monomer absorption. Applying pressure reduces the time required for a monomer impregnation. Higher the pressure, less time required. Lower the pressure, more time required to fully impregnate the monomer into the concrete voids. Then third one is that latex modified concrete. Here, in the case of the latex modified concrete, the polymer or latex will be added into the Portland cement concrete mixture during the mixing process. So here, hydration will also occur as well as polymerization process will also occur. So both cement hydration polymer film formation process occur together, and that's the co-matrix phases formed by both cement and polymer film formation process. We'll see with the help of the image also how that together process will carried out. Three-step process will be there. The first step, the polymer particles are uniformly dispersed into the cement paste phase, initially into the mixing phase. Step two, with the development of the cement gel structure, that is CSH gel, the polymer particles are gradually confined in the capillary pores. So whatever the capillary pores available after the gel formation, that polymer particles will go get into in that one. Step 3, with the removal of water during cement hydration, the close packed polymer particles on the cement hydrates coalesces into continuous films or membranes. While the further cement hydration process use that water, these polymer particles will surround the cement particles or the aggregate particles. The membrane bind the cement hydrates together to form a monolithic network. As the both the reactions act together or occur together, it should be form the monolithic network to get the intact property of the latex modified concrete. So polymer phase interpenetrates throughout the cement hydrate phase. Such structure acts as a matrix phase for latex modified mortar and concrete. The aggregate are bound by matrix phase to the hardened mortar and concrete. So latex modified concrete is produced by adding latex polymer during mixing. Now here you see the new word is coming, that is latex. So we'll see what is the latex. Latex polymer during mixing of Portland cement concrete. Polymer act as a here admixture or partial replacement of the mixing water. Polymer strands from network within the cement matrix. Here you can see last sentence you just now you asked that about the reinforcement that is there provides alkaline passivation protection to the steel similar to the conventional concrete. So if you see this image properly, this is the after the immediately mixing process. This larger particles shows the unhydrated cement particles. Smaller rounded one shows the polymer particles, and these are the lining one the aggregate particles. When the further first step, that is mixture of unhydrated cement particles and cement gel. Unhydrated cement particles and cement gel are there, means the hydration process is in continuation process. That time polymer particles will the surrounding of that one or will attach to surround of that one. After that one, once the hydration process proceeds further, the mixture of cement gel and unhydrated cement particles envelop with close packed layer of polymer particles. You see, polymer particles are closely packed that hydrated and unhydrated cements and aggregates as well. Here, that layer further increases, width increases, and that width increment depends upon the how much void is available into that concrete matrix. That means that this is the hydrated and unhydrated cement whatever available that one. So this is the surrounding film formation around all the inert material as well as the hydrated material. So because of that one, whatever the voids available, that will be occupied by this polymer film. So voids will automatically get closed. Certain amount of air still will be available, which will not fill with this polymer. But in the case of previous polymer concrete, the air will completely remove because we are going with the impregnation. Here, certain amount of airs will be available. So that also has certain advantages, which should, because of the certain amount of air available, the freeze thaw resistance will be the higher compared to the previous polymer concrete. So certain amount of air void should be there into the concrete. We also considering into the design mix, we consider 2% of the air, right? And if you want to go for the freeze thaw resistance, we'll go up to the 4%. So latex can be natural or man-made. So natural latex is obtained from rubber trees, where synthetic latex is produced through chemical processes. So what are the synthetic latexes? Copolymers of styrene, butadiene, acrylic copolymers, styrene acrylic, vinyl acetate ethylene, and polyvinyl acetate. These latexes consist of organic polymers formed from combination of monomers such as styrene, acrylic, butadiene, and vinyl acetate. Main thing is that latex is usually present as a basically dispersion of very small polymers into the water. It is a solution. Latex is one of the solution where whatever the small polymer particles will be available, that will be the range of or size having the 1500 to 2500 angstrom. That will be in micrometer 0.15 to 0.25 micrometer. That small amount of polymers or small polymer particles will disperse into the water. So how much? The solid content of latex emulsion is about 50%. Means 50% will be the water and 50% will be the polymers. That is the content of the latex. So when you are using Portland cement concrete and you want to add 15% of polymer solids, 1.15 by weight of cement. So at that time, you cannot, if you want to achieve 15% polymer, not latex, but latex has the 50% efficiency. So that time you have to add 30% latex to get the 15% by weight of cement. If you added 13%, because of its efficiency is 50%, then only you are getting solid 15% polymer. So since latex emulsion introduces additional water into the mixture, the mixing water must be reduced accordingly. Which additional water we are getting? Because latex, already we saw latex is a combination of 50% water and 50% of small dispersion of polymers. So that additional water we are providing with the latex, that's why whatever the water we are adding into the concrete, that make we can reduce whichever required for the hydration process. But along with that one, we have to consider the surfactants. Why we have to add the surfactants? When we are adding that small amount of the polymers, there is a possibility that polymers will come to closer and will coagulation will happen. To avoid that one, to get into disperse properly, we have to use the surfactants. But there is a disadvantage by using surfactants. When you are using surfactants, there is a possibility to have a higher amount of air voids. To avoid the higher amount of air voids, we can use the anti-foam agents. So these are like a connected each other. We can reduce the water content because you are using the latex, which is having the 50% of the water. Then to get it should not coagulation each other. That's why we have to use the surfactants, which will disperse all the polymers into the concrete matrix. Then when we are using surfactants, there is a possibility to have the air voids. To avoid the higher amount of air voids, we can go with the anti-foam agents, which will control the air voids into the concrete. So as latex particles coalesce and form a semi-continuous film, or moisture is retained around the cement particles, so allowing hydration to continue and reducing the need for extensive external curing. As this latex is forming the film we saw into the previous image, it is forming the film around the unhydrated or hydrated cement or the inert material, whatever will be available, that is aggregate or maybe any other. So that is forming the film. That latex film has certain amount of the water. So that water we can use for the further hydration processes also. So that's why external curing will be minimum in the case of concrete. So we can reduce the initial water also, we can reduce the external curing also. So that's why minimal external curing, whereas in the concrete applications, 1 day of moist curing followed by air drying is generally recommended. For that purpose only, as curing is also reduces, 1 day moist curing and after that dry curing is also fine for this type of the concrete. Moist curing is typically carried out using damp burlap or polyethylene sheets. So how these processes occur? First one is hydration of the cement. The chemistry and reaction processes of cement hydration occur in the same way as particular to the traditional or conventional concrete. With water being removed from the latex emulsion, the latex particles get closer. Who will remove that water? That water will be removed or consumed by the cement particles for the hydration process. As that water is consumed by the hydration cement particles for the hydration purposes, whatever the dispersed polymer will be available into that latex will get into the closure and will form the semi-solid or semi film around the hydrated or unhydrated cement particles. Next, coalescence of the latex. With continual water removal, the latex particles can eventually coalesce into film, coating the hydrate and aggregate surface with a semi-continuous plastic film that will give or that will fill the voids between the concrete matrix. So, what are the properties we are getting with this type of concrete? It affects your properties into the plastic stage and hardened stage. Plastic stage means you are maybe in the initial hardening stage, initial setting stage, or a couple of minutes after that one also. So in the plastic stage, the combined characteristic of the latex and antifoam cause some air to be entered in the mix. So that air will be helpful for what purposes? As a lubricant. So for that, because of that lubricant, we'll have the higher flowability. So we already we are reducing the water, so we want to maintain the flowability. That flowability is maintained by these entrain air voids. Another thing is that workability also improve by dispersing effect of surfactants. Whatever the surfactants we are using, that having the dispersion effect. Dispersing effect means the particles will repel each other or it create the distance between each other. That creates the again flowability or workability. Setting time of latex modified mixes is generally controlled by the hydration of Portland cement. Here, setting time is not controlled by the polymerization process. Here, it is controlled by the hydration process because we are using here water for the hydration purposes. However, the working time of the finishing may be shorter because latex will be dry and film formation caused by evaporation of the water from the mixed surface. So that will not allow more finishing time. For that purpose, we have to be the execution time will be the less for this type of the concrete. And once it is getting hardened very fast, the crust formation on the surface. When we are finishing, there is if you are there will be the crack or crust formation on the surface will occur. But in the hardened stage, if you maintain all this or keep in mind all these points, and we get into all finishing into the plastic stage, the hardened stage will give more benefits. It improves adhesion, tensile, flexural properties, permeability resistance, and chemical resistance. Now, here you can say the bond between the latex modified mortar and concrete is chemical in nature, forming a homogeneous combination of materials. Very important here it is that here bond is very strong and it is observed that it has been not broken. The concrete is not broken into the bond. It is broken into the parent concrete itself. But in the first case, we saw that polymer concrete case, the bond is not that much proper between the composite concretes. So here, this lattice modified concrete bonding is like more stronger than the polymer concrete. Latex also seals pores, significantly reducing permeability to both gases and liquids. Also, studies indicates that reduces carbonation depth and chloride permeability. Although, obviously, as we are reducing the pores, any type of the hazardous material will not come into contact or get into the pores. That's why carbonation, because of this no CO2 immersion, no chloride penetration. That's why better durability. So, where we can use this type of concrete? Emergency concreting in mines and tunnels, ceramic tile adhesives and grouting, swimming pool finishes, industrial floor toppings, production of high strength precast elements, and widely used as a repair material, especially for overlays on bridge decks and concrete highways. Now you can see here uses for the very important structures like production of high strength precast elements, repairing material for overlays on bridge decks and concrete highways. Because of its bonding is very stronger than the compared to the other two type of the polymer concrete. So that's why it uses also BSR. I'm not getting. Can you repeat it, please? Okay, okay. Okay, so mainly for the highway purposes they are using. Okay. No item is there. Okay. But this may be from sir's lecture, maybe from that Japanese code. So maybe it will not be available in the Indian code at this moment. Yeah, because sir has followed all the lectures based on the Japanese code only. So maybe this lecture is also from that one only. That this is a task also. You can find out which code has been given this conditions or these provisions. You can find out that one. So these all about the polymer concreting. So three different forms has their three different properties and different applications also. Last two, that is latex modified concrete and impregnated concrete. Cement involves for the hydration process. And the first polymer concrete, cement is not involved. Polymer acts as a binder itself. So these are some important points you can keep in mind regarding to the polymer concrete. Another important effect or another important topic is improving the quality of cover concrete. So cover concrete is very important as we are providing some defense system to the reinforcement bars. If the cover concrete is not properly giving strength and impermeability, then the reinforcement will be corrode very easily or very fastly. So that's why it is very, or we can call it as a first line of defense to protecting the reinforcing bars against corrosion. So actual cover, this protection afforded by the cover concrete depends on what actual cover provided means width of or thickness of the cover. If you see IS 456, the thickness of the cover for particularly different elements will be different. For the column, it will be different. For footing, it will be different. For slab, it will be different. And so that thickness, along with that, properties of the cover concrete. So whatever the concrete in that thickness, that property may not be the same as to the same center concrete. That is also here given. Cover concrete and hardcrete are different. The concrete, whichever is here and whichever is the cover, will be different. Can anyone tell me why it will be different? Why the properties at the cover concrete will be different? Because we are providing same concrete mat. We are using same concrete constituents for making the concrete column, suppose. And that concrete columns, the surface concrete cover will have the different properties from the hardcrete. We saw already in the previous lectures also why it is happening. Last time we saw not with respect to the um, formwork. We saw with respect to the evaporation. The evaporation of the water from the surface will be higher as compared to the heart of the concrete, right? Because the water will, whatever the water available here, it has to travel too much distance as compared to the surface. So for that purpose, we have the different properties of the concrete as the hardcrete and as well as the covercrete. Another thing is that whatever the formwork we are using, that is the main thing, creating the different types of the behavior into this concrete. So the increase in the water to cement ratio in concrete in the neighborhood of the impermeable network or formwork. We are using the impermeable formwork such as steel plates or the wooden plates, which will not allow the water to be evaporate from the surface or external surface, and at the same time it will giving the standard shape to that specimen. But what happens when we are going for the vibrating of that concrete? At the vibrating time, the water will be moved towards the formwork side. So that's why the higher amount of water available into the nearby formwork and wherever the cover we actually provided also. So when you are removing the formwork, that water will get evaporate and it will create the pores. So that's why the strength and the durability of this cover concrete will be less as compared to the hardcrete. That is also called as a weak near surface concrete. This it's called as term is called as weak near surface concrete. So that's why the kind of formwork we are using plays a very important role into the construction sites. But most of the times, like we are using plywood and steel, which are impermeable, right? So how we can avoid this difference between the covercrete and the hardcrete concrete? There are certain solutions are for that purpose. First one is use of sealant. So what is sealant? Sealant is a material which can apply over the hardened concrete surface. After the harden of the concrete, you can apply the outer surfaces, that sealant. So it will fill the pores because it creates a hydrophobic layer inside the pores. It will deep penetrate into your capillary pores, and it will not allow water or any salt material or any hazardous material to inside into the concrete matrix. If it is not allowing, it will giving the good durability aspect. But treatment is not permanent. It requires a periodic application. Periodic applications and widely used in bridge structures. So usually it is said that after the every 4 months you can apply this sealant, use of sealant. So automatically cost of the maintenance is also increases in this case. Another solution then, use of microsilica. Microsilica, very fine silicon dioxide particles, zero point 0.1 to zero point 0.2 micrometer, which has very high surface area. High surface area means the reaction will be faster, enhancing hydration reactions, improves strength and durability of concrete. How strength and durability of concrete we saw here, microsilica you are using into the concrete mixing itself. That's why if you are using this microsilica, it has a very small particles. It is create the hydration reaction initially also, and it is giving the lateral strength also, which is filling the pores by using the lateral formation of the CSH gels. We saw this plenty of times in the previous lectures. Like whatever the supplementary cementitious material available, we are using into the concrete, that is giving the strength into the lateral edge of the hydration processes. So that's why we'll get the microstructure very compact and dense, which will be less permeable. It will reduce the bleeding and porosity of near surface concrete. Why reduces bleeding? Because of the smaller surface will occupy all the water initially itself, and used widely in Scandinavian countries but limited elsewhere because the cost of microsilica is very high as compared to the other cementitious materials. So that's why its use is very limited. But Scandinavian countries like Denmark, Norway, and Sweden, they are using this one. Another solution is that control permeable formwork, CPF liners. We usually called as CPF liners. So CPF liners allow water and air to escape. How will you can see this image also? We Here this is the column, and we are providing to this formwork, and in the inside that one we have the CPF liner. The formwork is giving to the structural support for the your concreting before the hydration or before the hardening. CPF liner, what it will do when you are using poker vibrator here, you see, and you are vibrating the concrete to remove the air and voids into that one. That time, the water and air will move or travel towards the formwork. And you see the CPF liners will have this type of the gap, and it will allows this filter air and drain to move out of the nearby cover surfaces, but it will not allow to remove the cement particles. It will only allow to remove the air and water. So that is the beauty of these CPF liners. That's why if once air and water gets removed, we have the very compact and denser structures, so more durable and improving the covercrete properties as compared to the normal concreting, normal form of concreting. So that's why CPF liners are very popular. But one more thing is that CPF liners are also very expensive. That is approximately 20 to $25 per meter square and not easily available also. So that's why Professor Mishra sir has done some study into the IIT Kanpur. He used commercial liners, that is called Z liners, gunny bags, and particle boards for these purposes. So gunny bags and particle boards are cheap, easily available, and support green construction also. Because anyhow, gunny bags we are discarding, particle boards also we are discarding and easily available with less cost. So he used that one. So first of all, with the commercial liner, what he found that commercial liner, that is Z liner, shows the maximum improvement in surface properties. Gunny bag and particle board also improves the surface quality, but gunny bags are cheap, locally available alternatives to commercial CPF liners. But thing is that the whatever the fabric we have into the gunny bags, that impression will be on to the surface of the hardened concrete, and that we don't want to be that one. We want the plain surface. Higher water content increases CPF efficiency because higher water content, higher evaporation of that one, and it will not create any voids. These are the some of the solutions. Still, study is going on to find out the appropriate solution for these purposes. Further, another solution is that permanent formwork. The use of this type of permanent formwork in India is very less. Most of the you will see into the European countries this type of the formwork they are using, or maybe in some of the Asian countries like Japan. So permanent formwork means the formwork will be stays in place. Will not remove after the harden of the concrete. That concreting will be in that place itself. It will be act together along with that hardened concrete. So appealing, yes, o- okay, they are using. Okay, okay, so that will be like a profile still, like. Okay, so that's good that we Indian in India also now it's getting popular it seems. But I think so. It is using for the like government constructions or the private constructions. Okay, National Highway throughout India. Okay, okay, yeah, yeah. Okay, okay, bridges also. Yeah. So okay, in bridges, right? Hmm. So, different types of formworks available, permanent formworks, like hollow panels that are filled with the concrete, which remain in place and form a permanent structure. It provides, no doubt, it provides extra stability, protects the concrete from deterioration because one side is completely covered with that permanent formwork. So, it has advantages like reduces construction time for buildings, provides safer working conditions, enables faster project completion, requires less labor, but care is required to avoid hidden defects during construction. Hidden defects means you have to be careful that there will be no honeycombing will appear. The proper compaction should be there inside the this permanent formwork. So different types of permanent formwork. This is the profile steel. This is like a steel mesh which have some of the voids. Here's the precast concrete panel. Here precast concrete panels means some of the like these ribs will be available, and this is we can keep it, and over that one again concreting we can do, and that rib bit can be act as a connecting part of that concreting. So first of all we'll see profile steel. So common uses beam and slab type concrete floors with a formwork spanning between either steel or concrete beams. Reef floors within the depth of permanent formworks supporting members. Whatever the profile we'll have, that will support the members. So advantages: large span capability, lightweight and easy to handle. No doubt it is a steel sheet only. It will easy to handle, lightweight also. Stiffens the supporting steel frame, easy to cut and fit for irregular shapes. We can cut it and we can place it in any shape wherever required according to the condition or according to the requirement of the construction site. Good sealing by lapping panel edges. Disadvantages like care have to be taken. Reprofiles can be difficult after installation, like access to that one. An exposed steel sheet, that outer steel sheet may be vulnerable to the fire if fire exists. So that purpose also we have to be take care, like requiring extra reinforcement for fire resistance we have to provide. Next is steel mesh. Steel mesh will be have the small openings similar to the aggregate sizes. So common uses will be the construction joints in slabs, deep construction joints, vertical construction joints to the walls, wall and column formwork for further finishing, soffit formwork, curve wall formwork. Because steel sheet will have the less thickness, we can give into any other shape also. So curve wall formwork also you can use it. Advantages here also it will be light and easy to handle, easily cut and fitted to awkward shapes by unskilled labor also. No need of any skilled labors available to cut and fit into the places. And concrete pour can be monitored from the partially exposed face because the some of this like that voids will be there, so we can see the concrete will be poor, it will be going into the every place, it is not having any honeycombing or any voids into that one. Disadvantage: unformed space which is acceptable for stop ends to receive further concrete must be rendered or phased to achieve fair finish. What happens because of that small amount of voids will be there into the mesh one, there is a possibility that surface finish will not be the same, like into that voids that finishing will not be that one. So that is the disadvantage. If you want to proper finishing, that will not get into this one. Another, precast concrete panels. These precast concrete panels will be 2400 wide, usually reinforced by welded lattices. This type of W shape or some like a triangular shape welded bar lattices will be there, which project into provide mechanical linkage. So the concreting will be half concreting will be already done. So that's why it is called as precast concrete panels. And after concreting will be intact or fixed with that one, that reefs bars that will give the bonding between the new concrete and the old concreting. It can use for the composite concrete floors, steel or concrete beams, composite bridge decks, steel or concrete. So advantage: quick placement over large areas, large span capability, compatible with concrete structures. But here disadvantage is that it will be very heavy, so requires mechanical handling, may affect reinforcement detailing also. But if you have the very congested reinforcement, that purposes we cannot use this one. And positioning tolerance may cause creep issues. Sometimes you are using this width like 2400 but in actual casting, the width may get reduced or may get high. So that tolerance will not be there. So that will affect the further properties of the concreting also. So these are the like uh, formwork issues. So we can use different types of formwork to get the cover crete similar to the hard crete to avoid the further durability issues. So next we'll see compaction of concrete. Very small but very important. Why compaction is required? If the air is present, it will affect the strength of the concrete. If that air voids will be connected each other, it will create the durability issues due to the permeable concrete. So that's why compaction is very important. But compaction is very important. But how much time according to the particular concrete, that is also very important. You cannot compact too much and you cannot compact very less also. So optimum time is very important. Why we have to remove voids? To achieve the maximum density of the concrete. Vibration reduces internal friction and helps to proper aggregate packing. So vibration is one of the way to compact the concrete. If you provide the vibration, it will helps to reduce the internal friction between the aggregate, and it will go into their place wherever the space is available and will reduce the voids in between the concrete matrix. Further, it improves abrasion resistance and durability. Obviously, voids get reduced will reduce the permeability, creep, shrinkage and creep. Shrinkage, no voids, there is no movement of the water, so shrinkage cracks will not be there. Creep, creep. If the concrete structure is very dense, the load coming continuously, constant load that will bear by the perfectly that concrete structure, and it helps to achieve the required surface finish. But compaction is considered in two stage processes. One is aggregate particle move. When you are going with the concrete compaction, first of all, concrete fills the form and levels the surface with the help of the liquefaction. Means once suppose you are using the poker, concrete poker, you are going with the vibration. Initially, the slump will workability will get improved, and that will level the concrete surface. But the voids which are available into the concrete, that will take little more time to expel out from the concrete matrix. So that's why we have to be careful about the timing of the compaction. Compaction can be done by rodding, tamping, or vibration, but vibration is more efficient and popular. So concrete liquefies and the surface level, giving the impression that the concrete is compacted, but it is not actually compacted because entrap air takes a little longer to rise to the surface. So you have to do compaction until this is accomplished. That is until air bubbles no longer appear on the surface. If you see when you are going the vibrating table also, that concreting compaction using the vibrating table also, initially some workability will improve and the compact you will see the compaction will be fine. But if you continue little bit more time, the certain amount of voids or bubbles will see into the surfaces that is coming out of the concrete matrix. So you have to be take care of that one. So how it affects the fresh concrete? Proper vibration is necessary to. If it is excessive vibration, can cause segregation and mortar loss. Segregation means larger particles will from the depart from the concreting cement matrix or the fine concreting. Then concrete must be properly proportioned for good compaction. Mixes with the low fines are difficult to compact and may have high porosity. Why difficult to compact? Low fines will provide the higher cohesiveness, and because of the higher cohesiveness, more energy is required to compact. Similarly, low with low fines, higher cohesiveness or higher interlocking between the aggregates, and that will require more energy. And low fines is there, so that's why that whatever the low voids area or low void space is available, that will not fill by the fully. So that's why high porosity. Similarly, mixes with too many fines and high slump. Too many fines means either maybe more paste content or maybe the more fine aggregate content. High slump will also be there, and if you provide excessive vibration, it will cause segregation and excessive bleeding. So you have to find out the appropriate time according to your the concrete matrix or the concrete constituents. This is the schematic of that one also. You can see the first 3 to 5 seconds, the liquefaction of the concrete which allows it to the slump and fill the form. Next 7 to 15 seconds, the expansion of entrap air will happen. Then only we'll say that the compaction of concrete will complete. So total time is about both the processes including 10 to 20 seconds. Further effect on fresh concrete is that low workability, that is stiff mixes, very hard mixes will be there that requires higher energy or higher amount of the time for the vibration to get the fully compact that concrete. Particularly if you see the no slump concrete, we saw the roller compacted concrete, right? In that case, the roller you have to be uh, place over that concrete multiple times to get the properly compacted, and there we are using some one of the geotechnical rules, that is compaction with the optimum moisture content. So more workable mixes requires less energy, obviously. Whichever having the higher slump, less energy required to get into the proper compaction. If we provide still we provide the higher compaction, the segregation and bleeding will happen. Another, aggregate size and shape also affect. So larger aggregates, more effort required. Angular aggregates, more effort than rounded aggregates. Why? Rounded aggregates will easily have the lubrication in between the particles, but angular aggregates, what happens? It will mechanically interlock each other. So requires the higher effort, means higher vibration as compared to the rounded aggregates. So if we do not do properly the compaction of the fresh concrete, what happens into the hardened concrete? That entrap air reduces strength almost 50% for the 10% of the air. Proper compaction improves durability due to the reduction of the voids. Excessive vibration may remove air entrant bubbles, reducing freeze thaw resistance and durability also. Excessive vibration can bring too much mortar to the surface and create the latence onto the surface, reducing abrasion resistance. So, vibration must be carefully controlled to remove air without bringing excess fines to the surface. This plot you can see for 10% of the air voids, you are almost reducing your 50% strength. So that much effect you have the void onto the strength. Similarly, more voids, the durability will also be low. So voids has very wide effect onto the concrete properties. Over compaction, what it does, over compaction should be avoided during compaction because low workability mixes, it only wastes higher vibration energy. Low workability mixes, vibration energy loses. So we have to find out at what time we are getting the maximum density also. Can cause segregation where heavy aggregates settle at the bottom and cement paste rises to the top. When we are using like suppose you are doing the like column, you cannot place into the one place into one lift. Suppose large height column, you are pouring into the continuous lift. That time you are doing the some higher amount of the compaction for the lower part. So what happens, the cement particles will come into the surface, that will create the lattice, that a weak surface layer. And when we are giving another type of the another lift of the concrete for the over that one, that cold bond will be get formed, that is the weak bond between to the surfaces. So that should not be there. That's why we are sometimes we are removing that the weak surface also. Another adverse effects, honeycombing, formwork damages, because it's creating to the higher pressure. While more compaction, the pressure of the concrete will come into the adjacent formworks. Bleeding, water and cement paste rise to the surface, causing cracks and weak surfaces. These are all about the compaction. But how we'll do the compaction? Two types: hand compaction, mechanical compaction. Hand compaction, everyone is aware about. We'll do with the rod. Compaction rod, we'll call it as code has given certain dimensions for that rod. Used for the workable concrete mix usually, because where we don't want to give the more energy with the hand. Done using rods or tamping bars. Rod must reach to the bottom of the former. Concrete is compacted by repeated tamping. Usually, if we are using into the lab, into the cube, we will go with the 25 times into the three layer. If you remember, with the according to the IS code. But mechanical compaction is different from that one. Mechanical compaction is generally used wherever low slump concrete is there, like low water to ratio, water to cement ratio, high coarse aggregate content, heavy reinforced structural elements. That purposes we require to give the higher energy, and that we cannot possible to give it with the help of the hand compaction. So that's why we are going with the mechanical compaction. Three types of the mechanical compactions available: shock or drop table compaction, centrifugation, vibration, out of which vibration is more popular. So shock or drop table, generally used to compact very stiff and low slump concrete and mainly using precast concrete production. Shock or drop table means table will be there whenever we put the concrete into the some of the cube or something, some formwork. The table will do the get into some distance and then it will to drop like to the flow table. You are giving into the dropping like that, only it will drop with the certain frequency and certain amplitude. That will create the vibration into the concrete and will give to the compaction of that concrete. Centrifugation is that some what we called some cylinder type thing will be there, and with the motor that will be rotate. So because of the centrifuge force, centrifuge force means the force going away from to the center towards the surface. If it is a circle, the center from the surface going away from to the surface when we are rotating the that surface. So cylinder is rotating with the high speed, and because of the centrifugal force, the concrete will be the compaction onto the surface. So that is usually done for the manufacturing poles, pipes, and piles. Suppose you have the concreting pipes using for the sewer lines. That pipes it is cylinder type. That cylinder type will go with the centrifuge. So it will be the compact over the surface of that cylindrical centrifuge. Next, it is the vibration method. So vibration, it will be the internal vibration or internal friction, rearrange cement and aggregate particles to achieve the dense packing. So most commonly used vibrator is the poker vibrator onto the site. It will be consist of the poker with an eccentric shaft driven by motor. Poker is immersed directly into the fresh concrete. It will create the compression waves into the concrete. It can operate up to 12,000 RPM, 3,000 to 6,000 RPM. Its recommended vibration range insert zero point 0.5 to 1 meter spacing. Every suppose you have the long column or long slab, you can for zero point 0.5 to 1 meter spacing you have to vibrate that concrete for 5 to 30 seconds. Withdraw slowly. While pouring and withdrawing, you have to do slowly to avoid the tapping air. Poker diameters can be small as 20 mm for congested reinforcement also. Concrete layer should not exceed 600 mm thickness or 10 times of poker diameter. This is the limit of the poker. Suppose you are using the 20 mm poker diameter of the poker, so 10 times it is a 200 mm thickness of the slabs you can vibrate with that diameter of the poker. So 600 mm means 60 mm diameter poker you will require to have proper compaction for that thickness of the concrete. This is the upper limit for the poker concreting. So another types of the vibrators available for the higher thicknesses. We'll see. So vibration depends on the workability and the element type, right? Another type of vibrator is form of vibrator. That is we call it as external vibrator. We are not pouring into, we are not keeping into the concreting. So it is called a shuttering vibrator. So whatever the formwork we have, around that formwork we can keep it vibrator, and you can vibrate the material and get the compaction. Usually for thin and heavily reinforced sections, we can do that one. Why heavily reinforced sections? There we cannot use the poker. Typically vibration times 1 to 2 minutes for that purpose. You see this schematic. Suppose this is the external vibrator. This is the formwork, and you keep it here. And you are providing to the external vibration. This is the vibration waves are creating inside the concreting. So it generally used for compacting concrete through the vibration of the formwork. Suitable frequency. Now we have to be careful here about the frequency and amplitude of the vibrator, and it will be depend upon the size and design of the formwork, because the vibration should be conducted through that formwork also, and depend on the your specimen also and your thickness of size of the specimen. So high frequency vibration generally for the require high amplitude with low frequency for the very stiff mixes. Very stiff mixes, we have to provide the high amplitude to get the fully compacted. Very workable concrete, the amplitude should be very low. Typical vibration frequency is 3000 to 12,000 vibrations per minute. That is 50 to 200 hertz in frequency, and it gives better surface finish also. High when for the high frequency only. Another is table vibration, which is generally used into the labs also. Here is the principle. You can see these are the vibrators below the table. The table will get vibrate, and it will create these compression waves into the concreting surface, and it will compact on because of that one. This is the table vibrator type. These are the springs we have here. So table vibration use harsh and stiff concrete mixes commonly in laboratory methods. We all in the civil engineering laboratory will have this type of vibrators. Consist of a steel vibrating table mounted on a flexible spring. Typical frequency 50 to 100 hertz, and acceleration will be the 4g into 7g. Widely used in precast industries. See, table vibrator used in precast industries. Another type of vibrator that we saw, drop table, that is also used into the precast industries. Large vibration amplitudes are required for effective compaction, produces higher strength and density in concrete. Another type of vibrator is surface vibrators. This will be used generally into the if you want to vibrate your the bottom of the home surfaces. That type of this type of vibrator you can use it here. Principle because of these two Here compression waves will be create and will vibrate that thickness. Now this is also external vibrator. Here you can limit is that slabs up to 250 mm thick. Commonly used for precast slabs and retaining walls. Retaining walls, it is more popular compared to the precast one. And 3000 to 6000 vibrations per minute it is, and 50 to 100 hertz frequency, 5 to 10 g usual accelerations. Compaction efficiency depends on the static load, amplitude, frequency, and rate of travel. Rate of travel means you have to be travel with this one. Two-person will be there, one person here, one person here, and it has to be travel from here to here. Suppose this is the surface. You have to travel from here to here. The distance you have to find out on how much distance you have to be keep it in that one. Similar high amplitude and low frequency combination is generally preferred. Similar all the vibration external vibrations you have to go with the high amplitude and low frequency combination to get the greater surface finish. But what happens if we are not giving the proper vibrations to the concrete? Means it will maybe under vibration or it may be the over vibration. So it under vibration creates the honeycomb, voids or cavities into the concrete due to poor compaction. Sand streaks, linear deposits of the sand onto the concrete surface due to the bleeding, that is over vibration. Cold joints, weak plane. We saw that cement particles will come into the surface, and second lift, if you pour into the concrete, that weak bonding will come into the picture. Bug holes, small surface cavities caused by entrap air bubbles during the placing and vibration. Subsidence cracking. Subsidence cracking means cracks form due to the settlement of the some of the concrete around the reinforcement. Placement lines, visible lines between the successive layers of concrete caused by improper placement and compaction. Like this. This is the honeycombing due to the poor compaction. And this is the visible lines because of the proper. This may be the very stiff concrete or maybe not properly compacted. That's why it's the poor finishing is there and cold joint formation will be there. There is a possibility that ingress of the external hazardous material come into contact will go into inside and will create the durability problem. So these are all about the compaction. We already saw some of the precast concrete things in previous lectures. This is a very short things we will see. The precast industry is mainly popular because it is giving the good quality control over the surfaces or the concrete specimens, and particularly this yard you can see is this is the sleepers, railway sleepers. This is the sleepers casting yard, and this is the sleepers heading out casting yard. So mainly used for these purposes. Apart from that one, you can see the bridge girders also you can precast. So precast industry is very big which because of its popularity due to the greater quality control into the warehouses as compared to the site. So steps in precast construction will be the before and after. So pre is that production, curing and storage. Post will be installation and finishing. In between will come that transportation. So these all are the very important steps inside the precast construction. But in the precast construction, the curing will be mainly done by the steam curing. Steam curing means curing of concrete using water vapor at atmospheric or higher pressure. So temperature range will be mean between 40 to 70 degree if it is at the atmospheric pressure. Purpose will be early strength gain because we have to in the as we are creating into the warehouse, the continuous production process will be there. So we have to be create the early strength gain to remove the formwork as early as possible. Application, pre-stressing and precast plants to achieve high early strength, allowing rapid demolding and reuse of formwork. So steam curing used in pre-stressing also and precast plants also. So when you are going with the steam curing at atmospheric pressure, prefabricated elements are usually stored in a chamber and steam is applied over that one at atmospheric pressure. But there is a observation that slightly higher drying shrinkage and moisture movement will be there at the atmospheric pressure. Moisture movement, that is moisture movement from the concrete surfaces or concrete matrix. As the moisture is moving, there is a movement of the water that causing the drying shrinkage. But in the case of the high pressure process, the autoclave will be used for that purposes. So it is a closed steel chamber and the chamber must be steam tight. So continuous operation is not possible. Continuous operation means we kept a specimen into the autoclave and the autoclave is closed until that curing is not complete. We cannot keep it another concrete specimen. So that is a discontinued process. So temperature and pressure is controlled during curing. Temperature into the high pressure process will be always in between 120 to 160 degrees Celsius, and the steaming period is short. You use a pressure vessel, curing chamber with steam pressure above atmospheric pressure. Here we are going with the above atmospheric pressure. So that's why, as we are going with the above atmospheric pressure, high early strength and durability that will be there. But along with that one, it reduces the drying shrinkage, moisture movement, and efflorescence. So basically, two things are there. When you are going with the atmospheric pressure, there is a possibility to have the higher drying shrinkage and higher moisture movement. But when we are going with the high pressure process, there is a reduces the drying shrinkage and moisture movement. Along with that one, resistance to the sulfate attack also. This schematic, if you see how steam curing is being done. So initially it is will be the delay period, and then with a certain amount of the rate, the heating will be go from suppose 0 to suppose 50 we are going 0 to 50 will go per degree per hour, suppose we are considering, and then it will be the constant for 50 or 60 degrees Celsius for certain amount of time. Then cooling period will also be the not sudden, it will be also like gradually, and then it will come into this normal temperature. So this will be the steam curing process. Similarly, Professor Mishra sir has been used in IIT Kanpur. So outside air temperature is 10 degrees Celsius. So initial delay prior to steaming, they give it 3 to 5 hours after the casting. Then they increase the steam pressure or steam applied to the enclosure at a rate of 10 degree to 20 degrees Celsius per hour. So it increases, and after that it maintain constant, and it is achieved in 2.5 hours, and maintain constant for 60 degrees Celsius until the desired concrete strength is developed. And in their case, it has been developed in between 6 to 12 hours. And again, gradually the temperature decreases for a period of 2 hours with the 20 degrees Celsius per hour within a 10 degrees Celsius of outside air. So we cannot go with the direct high steam curing like high temperature. We have to go with the gradually increasing, then we have to maintain for certain time to get the desired properties of the concreting, and then you have to reduce gradually. So this is the standard procedure, and the timings like how much time you have to be keep it in the constant process and at what rate, that you have to find out for your particular concrete mix. Low pressure continuous process, we saw closed processes. Now we are seeing continuous process. Continuous process, it will be like continuously specimens will be moving inside that one. So concrete units are prepared, it will be most for the mass production, particularly for the sleepers, railway sleepers, that will be the mass production. There you can use the low pressure continuous process. So concrete units are prepared on a conveyor which carries a filled molds or pallets into a long tunnel where the steam curing takes place. It will be placed into the pallets and the steam cure or conveyor belt, and the steam curing will be the continuous process. In short high temperature tunnels, doors may be fitted to conserve heat, and this is the case haulage usually intermittent, the rope or conveyance advancing by the distance of one truck as the doors at each and end are open. So long tunnel may have a temperature gradient deliberately formed at each end, and this is the case. Doors may be left open without undue loss of heat. Haulage in this case is usually continuous. The thing is that door may be closed if it is a shorter space between the continuous low pressure continuous spaces. Doors of that tunnel may be closed to avoid the heat loss. And if the tunnel is too long and you have maintained the heat losses or temperature gradient at a certain places, the door open may will not be affect the loss of heat also. So depend on the your tunnel size or tunnel length. Then heating of curing chambers, the heat transferred to the surface heats the interior of the unit by conduction through the mold and outer layers of the concrete. The, the method of heating employed should produce the acceleration of strength required for the least expenditure of energy, and all the units should be heated to about the same temperature. So in addition to the external heat, the heat generated by the chemical reaction in concrete is expended in heating the concrete to the desired temperature. So along with the exothermic reaction, whatever the heat is creating, that heat is also used for the that expended heating in concrete to the desired temperature to maintain the temperature of that curing chambers. This is the images of the steam curing. You see, this is the steam curing. It is a closed one, and this is steam curing open one, which is at the atmospheric pressure. So this is the precast related things very shortly we discussed and we saw. So mainly about the quality control. Another is the if you are going with the mass production, you have to go with the continuous process of steam curing. And if you are going with the smaller samples, you can go with the closed process also. You can go with the atmospheric pressure and you can go with the above the atmospheric pressure also. So another very short and very important is that because as we all are know the we are all are, in the materials perspective trying to achieve the sustainability in every aspect. That's why because cement is producing higher amount of CO2, almost 6 to 8% of the all over the world. So we are trying to reduce the cement. We are trying to use the alternatives of the cements such as the supplementary cementitious materials. We are trying to use all the recycled materials or industrial waste into the concrete. For that purpose, research is going on. So another thing is that recycle materials. So how we are using recycle materials because it is a large generations. So collection points, MCD dump will be there. That material will come into the incoming at certain points. Then we'll go with the inspection. Will inspection of the what are the type of the material. Then we'll go for the segregation process. So we'll remove racks, plastics, metals, FRP sheets from that construction materials, right? Then whatever the construction and demolition waste mix that will come into here, whatever the pass, that whole bricks will come into here. That whole bricks we can completely use for the another construction, so that will kept separately for internal use. Mix C&D use. That mix C&D waste may be the some broken part of the aggregates, some broken part of the mortar, some broken part of the bricks also, and some cementitious fines also. So for that purpose, filters will be available. So out of that, about 200 that will reject and will come here. And here also big concrete blocks will come here. That will crush to 200 to 400 Dry process will go into 10 to 20 in size, 5 to 10 size, and 5 to 75 micrometer in size. Here that will come impact crusher size reduction to 60 weight process. Here 6 to 20 20 to 10 10 to 5 and 5 to 75 micrometer. Here we are using the dry process. Here we are using to the wet process. Wet process we are using to the water here. So what we'll do with this size of this C&D wastages? C&D wastage we can let's suppose recycle aggregates. So recycle aggregates we can use as the replacement of the natural recycle aggregates, but not into the very important constructions because we are till the date we are also not fully confident about the properties of the recycle coarse aggregates because when when it is going to the crushing process, there is a possibility to formation of the cracks over to that aggregates. There is a possibility to have reduction into the strength or crushing strength of that aggregates. Another thing is that whatever the recycle aggregates are there, if you if you saw the recycle aggregates, there is a certain amount of the thickness of the layer will be available over the surface. That is the mortar layer, and that is actually the ITZ, interfacial transition zone. And when you are using that recycle aggregates into the another concrete, another ITZ will form. So in that case, ITZ1 and ITZ2 will come into picture. So more weakened surface will form. So that's why the research is going on, and the certain amount, like up to 30%, is acceptable replacement. So, but beyond that one, it is a mock test you have to do, and you have to find out the properties of the recycle aggregates also, and the recycle aggregate concrete also, to find out the use of that aggregates into the your concreting. So IS 456 2000, which is the basic code for design and construction of concrete structures, allows aggregate and sand not drawn from the natural resources to be used in concrete. Right. So, however, it is difficult to have recycle aggregate to satisfy the requirements of natural aggregate. Means the real need is to look at the possibility and implications of lowering the bar of aggregates to be used in concrete for certain grades or applications of concrete. What it means, there is a not at all possible to maintain the same crushing strength or same properties of the natural aggregate by the recycle aggregates. So we have provided certain bar, means certain properties or certain provisions. So it should be fulfilled by that aggregates. So that bar we can reduce for the certain type of the concretes, which is not very important. There we can use the recycle aggregates, and we can maintain or reduce the use of the natural resources also. So this is the short, or you can say a little bit review of the week 8, which is the last week of this very interesting course, Development and Applications of Special Concrete. I hope you have get some idea with this, and once you go through the lectures, you will get it more idea and more detailed explanation from the Professor Mishra sir. Still you have any doubt, please ask. So anyone has any doubt? If it is not, then we'll move forward with the questions. Has anyone seen use of recycle aggregates into the government constructions? No, right? Still, the not the contractors or not the builders, and not even the Indian society has more confident about the recycle aggregates. So more research is needed in this aspect also. Okay. So if anyone not having any doubt, we'll move forward with the questions. So the first question is that in the context of latex modified concrete, consider the following statements. Statement 1: the monomer is impregnated through the pores in concrete by applying pressure and heat. Statement 2: both the cement hydration and polymer formation occurs in the concrete. So what will be the answer? First is both are false. Okay. Second, option second you are saying? Okay, first one is true, second one is false. So you see, they are saying latex modified concrete. Latex modified means third form of the polymer concreting. The monomer is impregnated through the pores in concrete by applying pressure and heat. It is not into the latex modified concrete. It is into the impregnated polymer concrete. That is second form. So first one is false. Second one, both cement hydration and polymer formation occurs in the concrete, right? Because water is available, cement is available, so hydration will also form, and at the same time, polymer formation will also form. So statement two is correct, one is false. Option second. Here it is wrongly. Option second is there. Sorry, third. False. First one is false, right? Na? First one is false, second one is true. Right? Understood? Any doubt? Okay. Second, in the context, yes. Anyone saying anything? Okay. Second, in the context of using precast concrete units as part of construction plan, consider the following statements. Use of steam curing at the plant facilities, earlier release of formwork. Statement 2, the members could be vulnerable to toppling unless they are appropriately secured. So, what will be the answer? Anyone? Hmm. So, I will give hint for the second. See, the precast unit will be the cast into the warehouse, right? And it may be the very long length or very long column will be there or larger length beam will be there. So if you want to see keep it a large column into the place, there is a possibility it will be topple until and unless you are not providing any security or any bracing for that one to support. So in that aspect, this statement has been given because if you are casting onto the site, there is no need to support anything apart from the formwork. But while fixing, we have to give the support. So what will be the answer now? Right, answer one. Both the statements are true because steam curing also we are using to release the early formwork because it increases the early hydration. Statement three. In the context of polymer impregnated concrete, that is PIC, consider the following statement. One, monomers are added as additives in fresh concrete mix. Statement 2, PIC has low permeability than conventional or normal concrete. So what will be the answer? Both are false. Okay. See, the first statement is that monomers are added as additives. Wrong. It is not added as additives. We are pressurizing and keeping into the pores, right? So first statement is wrong. Second, you can see PIC has a low permeability than the conventional normal concrete. This is true, na? Uh, Statement two is true because we are pouring the polymer into the monomer into the pores. So pores will get full and will not allow any external material into the inside. So permeability will be low than the conventional concrete. So first one is false and second one is true. So any doubt in that one? Okay. So in the context of high pressure steam curing of concrete, consider the following statements. Statement 1, it increases the earliest strength of concrete. Statement 2, it reduces a drying shrinkage in concrete due to an increase in moisture movement. What will be the answer now? Okay, any other? See, first statement, it increases the earliest strength of the concrete, right? Any type of steam curing increases the early strength for the early removal of the formwork. Now, second statement you can see, it reduces the drying shrinkage in concrete, right? It increases the drying shrinkage. But half of the statement you can see, due to an increase in moisture movement. No, if that moisture movement increases from the concrete, the drying shrinkage will be the high. As drying shrinkage is reducing, moisture movement will be the less. That moisture movement is not about the steam. That is about the inside the concrete movement, concrete moisture movement. So that's why statement two is false, and the first one is correct. So somewhat tricky second statement. So that's why maybe you got confused. Yeah. Next, in the context of compaction of concrete, which can be considered to occur in two phases. Statement 1, phase 1 involves redistribution of coarse aggregates into a more compact configuration. Statement 2, phase 2 involves gradual removal of entrapped air. So both are correct. Okay. Any other answer? Right. Because yeah, this is the like we saw 10 to 15 to 20 seconds process. That is phase 1. It will create the first of all slump like workability, and then that workability allows to surface finish, and then gradually removal of entrap air will happen, further continuing the vibration or the compaction process. So these are the two phases systems. So in the context of steam curing used for concrete, statement 1, it should not be used for very large members. Statement 2, it facilitates early removal of formwork, which increases the productivity in precast plants. So what should be the answer now? Second true, right? What about first? Hmm? Okay. So all are agree on the both are true, right? Because already we are seeing that precast members will be very high. Like sometimes the bridge girders also. So that is very long and very large members. So it's not about the length and size of the members. It's if it is depend on the length of the tunnel we saw, then it will be the different question. So in the context of concrete, statement 1 says control permeability formwork liners allows bleed water to escape and reduce porosity of the concrete in the neighborhood of formwork. Statement 2 says use of microsilica in concrete increases the bleed water when being placed. One true, second false. Hmm, right. And here it has given increases. So that's why first one is true, second one is false, right? Correct, na? Yeah. So answer will be the second. So in the context of using polymers in concrete, consider the following statements. Statement one: during the polymerization process, monomer molecules chemically attach themselves to one another to form chains. Statement two: in polymer concrete, both the polymer and cement acts as a binders. First true and second false. Hmm. Right. So here we have to understand that polymer concrete has three types, right? That is, one is called as polymer concrete itself. Second one is impregnated concrete, and third one is LMC, that is lattice modified concrete. So according to that one, polymer concrete only binder is the polymer only. So that's why in polymer concrete, both the polymer and cement act as binder. It's wrong. Statement two is wrong. And statement one is, during the polymerization process, monomer molecules chemically attach themselves to one another to form chains. This is correct. So what will be the answer? Answer option number two, right? In the context of compaction of concrete, statement one says the first thing that happens as the compaction of concrete is commenced is the escape of entrapped air from within. Statement two, the fully compacted lack of fines in concrete results in a porous microstructure. So what will be the answer now? Both the statements are a little bit tricky. Think properly and give a proper answer. First one is false. Second one is true. Okay. Any other answer? So answer is correct. First one is false. Second one is true. So how the first thing that happens as the compaction of concrete is commenced is the escape of not entrap air. Entrap air is the phase two. The first phase is slump increases, that is workability increases, and levels the concrete. That is the first phase. Second phase will be the entrap of the air. That's why first statement is wrong. And what second statement says? Though fully compacted, lack of fines in concrete results in a porous microstructure. Why it happens? We saw already. Although we are having the fully compacted structure, certain amounts of small voids available wherever large aggregates will not be kept into the put into that place. So that place will be occupied by the fines only. So as fines will be the less, that space will be the empty. That space act as a porous in nature. So because of that one only durability affects. So that's why statement 2 is correct. Although fully compacted, lack of fines in concrete results in a porous microstructure. Next, in the context of cover concrete, statement 1 says the efficiency of permeable formwork liners is increased with the use of higher water content. Statement 2, in a rational scheme of things, the thickness of cover to be provided may be reduced if a higher grade of concrete is used. Another very important question. So both are true. Okay. Any other? So first statement we already saw into the explanation itself. Higher water content is there. It will move easily through the air surface, through the CPF liners. Okay. Second, that's the first statement is correct. Second statement, we already saw high strength concreting. So high strength concreting is directly with respect to the water to cement ratio. Already we are having the less water to cement ratio. So less water to cement ratio, because of that one we are having the whatever the unhydrated cement will act as a filler between the pores, less amount of pores. So that's why thickness of the cover to be provided may be reduced if a higher grade of concrete is used, because smaller thickness as compared to the conventional concrete is also providing defense system for the reinforced bar to avoid the corrosion. So both the statements are true. Any doubt in this one? Anyone? Okay. So in the context of compaction of concrete, first statement, high amounts of fines with high slump cause segregation while compaction. Statement 2, selection of form vibrators depend mainly on the type of concrete to be compacted in the form. What will be the answer? Second, second true, first false. Okay, any other? First false, second true. Okay. See, first statement we already seen. High amounts of fines already giving the cohesiveness. But if it is a high slump, because of that one, segregation will happen if we are going with the high compaction. So that's why statement one is true. It is not false. Second, selection of form vibrators depend mainly on the type of concrete to be compacted in the form. It is not only depend on the type of concrete. It is also depend upon the size of the specimen. That is thickness. If you are using the external vibrators, we already saw the surface vibrators has a 250 thickness slabs you are using. Another type of vibrator you are using almost 600 poker type of vibrator, internal vibrators. So say up to we are going to maximum 600 So thickness or size is a main important parameter selecting to the vibrator. It's not depend on the type of the concrete because little bit stiff concrete and little bit compact workable concrete also you can compact with the vibrator. That's not an issue, but thickness has the main deciding parameter or the size of the specimen or size of the concreting. So that's why statement 2 is wrong. Okay. In the context of compaction of concrete, statement 1, for stiffer concrete the time of vibration using an internal vibrator may be reduced. Statement 2, an internal vibrator immersed in a fresh concrete generates rapidly recurring circular compression waves. So, what will be the answer? Think properly and give the correct answer now. First one is false. Okay. Second one. What about second one? Hmm. Right. Second one is correct, and first one is first one is false. Right. So for stiffer concretes, the time of vibration using an internal vibrator may be not reduced. It should be high for stiffer concretes to get the proper compaction. For workable concrete, it should be low. And statement 2 says an internal vibrator immersed in a fresh concrete generates rapidly recurring circular compression waves. That is correct. So statement 1 is false and statement 2 is true. So option will be 3. So these are the some of the questions from this week 8. I hope you understood, and if you have any doubt, please let me know. If you have any doubt from previous sessions also, please let me know. Anyone? So no doubt. So This is the our last session. I hope you all enjoy the session. And yeah, and one more thing is that uh, this is what we called. You have complete. Maybe you all have going through the lectures or about to complete the lectures also, and you will have the exam in this month only, right? On what date? 29th. Okay. So all the best for all of you. Yeah. 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 And thank you all for joining also. Because of you only this session has been happen. And yeah, yeah, yeah. Thank you for your yeah, 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 and yeah, yeah right, yeah, right, yeah, yeah. Even yeah, 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 yeah. Yes, somewhat tricky questions are there, somewhat. No, right? Yeah, yeah. Right. Actually, I am also learning by teaching only. Yeah. So that also benefits me. Yeah, I today Professor Mishra sir has thought to join, but he got some work, so he is not able to join. But still, you have some doubts. You can write him. He asked me to ask all of you if you have any doubt related to the concrete. You can write him on his mail. He, according to his time, he will able to answer. So, no, any like field related or any course related, any doubts you can ask him, and he will be always available. He want to share this message all of with you. So, I yeah, sure, sure. You can connect me. I have not shared my email ID if it is there, but if it is possible, you can connect me on LinkedIn also. I'm available there. So I will write my email ID here also. Yeah, in the chat box, I have written my mail ID. Yeah, yeah, yeah. Same, yeah, same like objective. And similar, if you gone through all the lectures and all the assignments, it will be easy to get higher amount, higher marks. Okay, okay. So all the best and thanks for joining once again. Yeah, yeah. Okay, yeah, thank you. Okay, bye, good night. Yeah, yeah, good night.